Okay, so far we have looked at some of the commands that you can use to create complex surfaces, but one of the straightforward commands to use is extrude curve. And the way it works is that you can create a cross section and then type in extrude curve, and you can see that it's being extruded and that your surface is being created. So this is an easy command that actually becomes very handy when you do modeling. So today I want to show you how to model 4 intersecting vaults, and I'm going to bring the picture here not to trace it but to have it as a reference. So as you can see, there are 4 arc cross sections that are extruded and then they are intersected in the center. So I'm going to start by creating these arc cross sections. If I go to curve, arc, and then there are multiple ways that you can create an arc. I'll start with this start and direction method, and I go to either front or right view. Pick a point for the start point, pick a point for end point, and then you can see this tangent line that is defining the direction. I will make sure it is in the Z direction, and here's my cross section. So in the picture you see that there is a square floor plan for our arc. So I go to the top view and draw that square floor plan to guide me to place the arcs. The other thing that I need to do here is to create a cross section here. I can either go to my right view and redraw the arc. I want to show you how to use a rotate 3D command though. That's why I copy it on the other edge of my floor plan, and then I type in rotate 3D, and you see that it pops. It's the second command that auto completion shows you. Select the objects to rotate. This is my object, and I hit enter, and now it asks to define a rotation axis, and it will rotate it around that axis. If you remember the right hand rule, that's how actually you do it. So I pick this point as the start of the axis. I go to my right view to create the axis, and now I have an axis. Now the command bar asks me to define the first reference point. Here's my first reference point, and then the second reference point, I can rotate it or place it anywhere. I want a 90-degree rotation, so this is my second point. Okay, so now I have 2 cross sections. I want to extrude them. I like to do the extrusion in a different layer than the one that I have my curves in it, so that I can easily turn them on and off and see what's going on. So I go to my layer 1 and I type in extrude curve. I extrude my first cross section, and here the second cross section. So now I see that it starts to look like the image that we wanted to model, but not quite yet, because geometrically these are 2 half cylinders that happen to pass through one another. What I want to do is to extract these intersecting arcs. There is a command for it that is intersect. If you want to know where it is, you can go to curve from objects, and here is intersection. So it asks me to select the objects to intersect, object 1, object 2. When I'm done, I hit enter, and the intersected lines are created, and they are also selected. That's why they are shown in yellow. While they are selected, I can right click on my default layer or a different layer that I want to move them to, and say change object layer. So now that I deselect them, they are shown in black. So now that I have them, I want to use them to split my 2 half cylinders and get rid of the parts that I don't want. So here in the left side, there is the split menu, and I click on it, select objects to split. My two half cylinders are selected. When I'm done, I hit enter, and now my cutting objects, select cutting objects. I select these two black curves and hit enter. Now they are split, so I can select the ones that I don't need and delete them. Okay, so this is the four intersecting surfaces. As you can see in the picture, there is a thickness to it, whereas these are thin paper surfaces. So how can we get from the surface to the thickness, thickened vault or surface that we see in the picture? One way would be to try to offset the surface. Let's see how it goes. So if you go to your surface menu and choose offset surface, you'd need to select the surfaces, and then when you're done, first it shows the direction of the surfaces. If you remember, there is this dir command that shows the direction of the curves and surfaces, and right now the direction is all pointing up. It really doesn't matter if they are pointing up or pointing down. You can set a positive or negative value to distance. What matters is that you want the direction of the surfaces to align. You don't want two surfaces to point upward and two of them point downward. If that's the case, you need to make sure that two of them are, the direction of the two surfaces are flipped so that they all align. And I also have the option of making it a solid, which I can click yes, and let's move with the default to see what happens. So I hit enter, and it gave a thickness to it, and each one of them seems to be a closed poly surface. To check it, I can go to Analyze, Edge Tools, Show Edges, and I first look at all of the edges, and then I see if they have any naked edges, which we don't want to have. So this one seems to be a valid poly surface. However, when all four sections of this intersected vault was offsetted, something weird happened in the legs, and they seem to be intersecting not in a quite right way. I can undo and maybe try offsetting it in a different direction. So let's say instead of 0.2, I type in negative 0.2 to see if that resolves it, and then it's still, let's make sure it's solid and hit yes. Okay, so it extruded in a different surface, in a different direction, but it's still making that weird edge for me. So here is the point that I want to take a step back and see if I can try a different modeling technique to get solid vaults that are similar to the picture that I brought in. Okay, so for the alternative modeling technique that I want to show you today, I will go all the way back to the step where I created this cross section. Instead of creating one arc, I will create a cross section of an arc, and then repeat all of the other steps that I took. So here I will first copy my arc, and I like to copy them diagonally. When I do that, it allows me to visualize it in both front and right viewpoints without them being blocked by the other object. I do the same for the cross section. I copy it and I put it here. Okay, so let's try offsetting the curve here, and you can see that it's the default value is 0.2, and it's creating a closed curve for me. So here it is. Now I have the thickness embedded into the cross section that I want to create. I will repeat all of the other steps that I did. I will copy it here. Then I will rotate 3D. This is a cross section. This is the end point. I go to my right view, select the axis, then select the rotation point and bring it here. Okay, so I have these two intersecting, these two cross sections, and then I go to my layer 1, extrude curve, curve 1, curve 2. Okay, I have the two half cylinders. This time they both have a thickness to them. Then I type in intersect them together to retrieve the cross sections. Okay, so now you can see that actually this is a very good exercise, because you see the way they intersect is very different on top from the bottom. On the bottom there is this curvature to the way that the offsetted portion of the arcs intersect, as opposed to the straight lines that we see on the top. And now that I have the intersection curves on the top and bottom surface of the surfaces, I use the split again, and I pick my half cylinders as the object that I want to split. And then for the cutting object, I make sure I select all of these curves that have been generated. And when I'm done, I hit enter and I delete the parts that I do not need. Okay, here is my intersecting bolts, this time with a thickness, and you can check each portion by going to analyze, edge tools, show edges. Okay, so you can see that all edges, the top of the bolt has edges that are different from the bottom part, and that might be the reason that the offset command could not generate this complex geometry for us. Let's see if it has any naked edges, and it does have a naked edge. If we want to see it better, I can copy this and bring it here, and you can see that it's open here. We can try booleaning them to see if that works. Boolean 1, 2, 3, 4. Okay, it's one boolean geometry, and this time if I want to analyze it, it still has some naked edges underneath it, which we must check to see if we have missed something. When I want to do that, oh yeah, actually we didn't pick the bottom surface in our boolean, but deleting it permanently is also a good way to check your surfaces. Okay, let's select these remaining surfaces one by one, and to be sure I will turn off my curves layer and select the window to select everything. Also try joining them, and then go to analyze, show edges, naked edges. Let me copy it here. Okay, let me try something different. I want to join this surface. Let's take it to a different layer. Change object layer. I want to check to see actually it's something inside our vault, how much it affects it. versus outside. So let's delete this one and then delete this one. Okay, so it seems that there was something in between, and now I have only these two. Let's see if I would be able to join them together. Okay, it worked. I could join them. And if I want to check my geometry, okay, it doesn't have any naked edges. So the reason that I insist on checking and analyzing the geometry for naked edges is if you are modeling for fabrication and let's say you want to 3D print this geometry or you want to do another operation on it, the geometry needs to be clean to allow you to do those extra steps. So here is the second modeling approach that created these 4 intersecting vaults with a thickness. I hope you learned from this video and enjoyed it. Have a good day and bye everyone.